Let's get back after getting this 07K together. If you guys remember in the last video, we just got this girdle all installed and all sealed up and it's ready to go. So now we need to get this timing cover, the timing cover on this side of the engine, sealed up and installed. And then we need to modify this oil pan to use a different turbo drain fitting because the swivel fitting that I had on there has been a leaking problem and I don't want to reuse it. So I'm going to redesign the pan to use a different fitting and hopefully eliminate that problem. We're also going to need to hang all the ancillary stuff on here, the whole turbo assembly with header and everything. We need to modify this power steering pump bracket to straighten out this pulley and hopefully fix our belt coming off issues at high RPMs. So I'm going to try to get as much of this done today as I can because I'm starting to get busy in the machine shop again. So I need to get this thing done and ready to go back in the car. So first things first, I got to get this timing cover on, but I got to go get this thing all cleaned up, get this main seal knocked out of it, get all the gasket maker or RTV off of it. And I'm a little worried about this cover plate here for the vacuum pump. So this is a vacuum pump delete plate. The vacuum pump is typically oiled by the oiling system, and this isn't really a tight seal here where it goes into this bore, and that's where the oil hole comes through. So I think I'm gonna make something to fill this hole so no oil pressure can be lost out of this vacuum pump oiling port. All right, so I got this all cleaned up. Let's see if we can find a way to plug that hole. Just under 6 millimeters. It's about 5.8 millimeters. So I think if I can find a 6 millimeter pin, that might work to plug that. So one of the shit parts about being an American machine shop is everything in here is standard. So this is a 6 millimeter hole. I have tons of these 1/4 inch dowel pins. So I think that what I'm gonna do is I'm gonna just ream this hole out to accept a 1/4 inch pin instead of trying to find a 6 millimeter. So I just went and blew this out with air to get the aluminum chips out. And I just validated my thoughts on this because I blew air around the perimeter of this block off plate for the vacuum pump and it blew all the chips out of this hole. So that tells me that this was a huge oil leak as far as reducing oil pressure. So I'm really glad I'm plugging this. There we go. We'll just replace our little O-ring. Boop, all sealed up. Perfect. All right, so this thing's all cleaned up, ready to go back on. Let's talk a little bit about this main seal. You can see how it got folded over. Now, I was pretty positive that I got this on nicely when I installed it. And I was talking to one of my customers that I sold a girdle to who's making really big power, like 13 to 1400 horsepower in one of these engines. And he was having the same issue, and he believes it's happening under heavy boost and heavy crankcase pressure. It's actually the pressure folding this gasket over. So especially when an engine's fresh and you're getting a lot of blow by past the cylinders, I think that possibly this seal is not really designed for that because this sealing ring is very thin. So I think crankcase pressure might be folding this over after it's installed. But he did have a solution for that, and that is to use this one. This is a spring-loaded, old school style main seal. It's got the install tool in it, so that's why it looks funny. But I believe it's from a VR6, and it is L-ring part number 829056. There's the dimensions of it. And this is what he's been using in his big power car, and he hasn't had any issues since. And this made a lot of sense to me because we didn't have an initial oil leak out of the main seal. It wasn't until we were on the dyno pushing the first little bit of boost on a pretty fresh motor that we started getting that main seal leak. So I do think maybe that crankcase pressure folded that over. Also, this engine and this seal was never designed to see a lot of crankcase pressure. We do have really good crankcase ventilation, but you can't get rid of all the pressure. So that made a lot of sense to me, and I think that will probably solve the problem with that rear main seal. We just need to get some RTV all around this gasket sealing surface here and then install this sucker. But there's one thing we cannot forget, which is this little guy. This little chain guide for the timing chain. This needs to go right here. This is loose because this tensioner is kind of compressed because I rotated the engine backwards. to make room to install that. So typically this has 2 pins on the factory lower oil pan, but the way I designed this was to use this surface here to support the backside of this chain tensioner, and it only uses the single pin. The reason for that is you can't put the second pin in because there's a stud going through there. This proves to work just fine. So you just drive that pin out of the factory oil pan and drive it into the girdle and you're good to go. So let's get gasket maker on this hog and we'll get it installed. All right, and now that this engine's been sitting for a while, for the haters, I'm gonna go ahead and re-torque this whole bottom girdle, just to make sure nothing has relaxed and we have proper torque. Looks good. Third time's a charm. All right, let's get this rear main seal installed. So these TTRS cranks have this pin in them. So I just cut a little hole in this installation tool with some nippers to go over that pin so that it sits flush. I've got this piece of 3-inch pipe with a cap on it, and that fits this seal pretty perfectly. So that's what I'm going to use to drive it in. But first I'm going to oil these surfaces, the outside surface of this seal and the surface of this install tool so that everything goes on smoothly. All right, the last thing I'm doing before I modify that oil pan is I'm going to seal up the top end of this engine with this brand new, nicely anodized valve cover. Check that out. That looks pretty nice. I wasn't sure when Vafa said he wanted that red valve cover, but it does look really good. Pretty cool. So next I gotta modify that oil pan for a different turbo oil drain setup to get rid of that leak. Well guys, I forgot to film it, but I got rid of this crappy swivel fitting that was in the oil pan, and I modified a right angle fitting and welded it. So now I have a welded in fitting for the turbo oil drain. No more leaks. Okay, so we've gotten everything pretty much buttoned up. I got the flywheel and clutch on, so that whole side of the engine's ready to go back in the car. Oil pan's on and sealed up. Basically, last thing I have to do here is try to align this power steering pump better with the axis of that belt from the main pulley. I have this rear bracket actually loose, and this still is at, I don't know if you can see it on video, but it's still at a slight angle. I'm gonna maybe adjust, maybe just do some filing on this bracket to try to get it to align better. And then I'm gonna maybe do some bending and some opening up of the holes on this bracket to where it bolts up solid and is actually in alignment with the pulleys. Okay, so trying to figure out the alignment on these pulleys, I'm using this straight edge, just setting it down in the root of the belt V's there, and I'm getting kind of a measurement off of the face of each pulley. Looks like we've got about maybe about a 40 thou difference from faces. So if I put this straight edge along here, I should have about a 40 thou gap to this pulley, and it should be straight in the same plane as this pulley, which it is not currently. So I'm gonna try to make some adjustments to this bracket to get it just right, and then I'll make some adjustments to the bracket that goes on the back of it to get that just right. All right, so after a fair bit of finagling on both this bracket, filing it down to get the angle correct, and then this back bracket over here, messing with this, bending it, and trying to get all these bolts to come into plane so that it would bolt up free without putting undue stress on this and inducing an angle. And now I've gotten these pulleys to come into alignment pretty much perfectly. So I think that part will be better, but I do want to make some sort of a idler pulley out here so that this belt length that goes across here, when we hit the rev limit or get off the throttle at high RPMs, it doesn't slap, leading it to loop and unhook itself from the pulleys. So I want to have some sort of a support on this bottom long run of the belt. So I'm going to try to figure something out. Maybe I can use these bolts to mount something to with a little pulley on there, or maybe these face bolts or something. I'll figure it out. Okay, so I made this little pulley. I had a bearing sitting around that I used, and I made this little pulley to function as an idler, and that's gonna just ride on the belt right about there. And so now I just need to make a bracket that'll bolt up to these two bolts and mount that little idler. And that way this long section of this belt won't fucking blah, 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 and jump off the pulleys. All right, here's what I came up with, guys. So I just used a little piece of angle and just made a nice little bracket out of it. Use those two existing bolt holes. Have my little pulley. I made a spacer for the back side and a big fat washer for the front side. And I'm just using a serrated nut on the back side. So we should be all good. And it just puts just a little bit of an idler on there. So I think that'll cure our belt issue. All right, guys, I got this thing just about ready to get set down on my little hydraulic table there. That's what I use to put this whole subframe and engine back up in the car. Got to clean that off, but I wanted to show you guys some of the little stuff I made here. So if you look in here, this This is the thermostat housing, and it uses the Boost Brothers Garage thermostat housing. That basically adapts it to a 1.8T thermostat housing, and I used an aluminum 1.8T thermostat housing and welded that pipe to it to get my coolant line to come out to the front of the engine. Back here, this is the Boost Brothers fitting for the back of the cylinder head, and I made this hard line here that brings that coolant line up to the front of the engine again, so we have our inlet and our outlet. So pretty Sano setup. They're pretty much on the same plane there. And then I also have fittings welded into this for my turbo coolant lines, and same here. So this black line here is just a modified version of the stock coolant hard line. I welded it all up, cut it up, used some different tubing, and made it fit nice and snug behind the engine here. And then it's got a turbo coolant line fitting for it also, both -6 there and there. And then these hoses go directly to the heater hoses in the car. Took quite a bit of fabrication time putting the engine in and out to get these to line up just perfect, but it worked out really good. So basically I'm ready to put this engine on that hydraulic table, and then I can start hanging all the turbo system on it. Well, there you go, guys. It's all back together, ready to go back into Vafa's Porsche 968. That was a whole lot of work to fix just a few little things. As you can see, Vafa wanted a little more color on this engine, so we did the red anodized valve cover, and I flame anodized all the titanium charge piping and the coolant hoses to give it just a little more pop in the engine bay. To see everything we did, make sure you go back and watch the previous videos. But basically, we took this engine apart, modified the oil pump for more oil pressure. We got rid of the check valve in the oil filter housing. We plugged the little hole on the rear timing cover, which is the oil feed for the original vacuum pump. So all of those modifications will hopefully help fix our low oil pressure issues in the engine, and mainly in the cylinder head. Beyond that, we checked the bearings, the main and rod bearings, those look great. We figured out a fix for the rear main seal to stop the oil leaks there, and we modified the oil pan to stop the oil leaks there. So again, a whole bunch of work just to fix those few little things, but I think this engine is going to be a lot better because of it. Hopefully we'll have a functioning VVT now, and we'll be able to tune that up on the dyno with the Max ECU Pro controlling all of that. So we're not really going for more horsepower in this engine, but we are looking for a broader torque curve and a more usable torque curve. This is a street car, and street cars aren't a lot of fun if they're super laggy. So getting that VVT working is going to help with our lag issues and turn this engine from a really peaky power curve to a more broad power curve. So we'll have more torque down in the mid-range, and we'll still be able to switch that cam timing back to its rest position and still make those high peak horsepower numbers. So if you've been following along, hopefully you've learned something, hopefully something in general, or maybe specifically about this engine. In the next video, we'll be installing this engine back into the Porsche, getting everything put back together, getting fluids in it, and getting it running again for its trip down south to get a whole bunch of suspension work and possibly some wide body work. I have yet to see what Vafa is going to do there, but hopefully the car ends up really cool. And then it'll come back to us for tuning. We'll get that VVT tuned up and ready to go. So if you're enjoying these videos, hit that subscribe button. Please comment with your questions down below, and we'll see you in the next video.